What if the entire universe is whispering to itself through an invisible thread? A cosmic secret woven into the fabric of reality. Picture this: two particles born together, separated by light years, yet still dancing in perfect unison. Change one, and the other responds instantly, as if space and time don't exist between them. This isn't science fiction. It's quantum entanglement, the universe's most baffling magic trick. Now, stretch that idea across the galaxy. What if advanced civilizations aren't using radio waves or lasers to talk, but this eerie quantum link, a network so fast, so silent, that we've been eavesdropping on the wrong channel all along? Einstein called it spooky action at a distance. But what if that spookiness is the internet of the cosmos? Stick around, because by the end of this journey, you'll see the night sky not as a silent void, but as a crowded room, buzzing with conversations we're just learning to hear. Now let's peel back the layers of this cosmic mystery. Imagine you have a pair of dice, not just any dice, but magical ones. Roll one here on Earth, and its twin, sitting on a planet in Andromeda, instantly shows the same number. No delay, no signal traveling between them. That's quantum entanglement in a nutshell, a connection so profound it defies our everyday intuition. These particles, whether electrons or photons, are like cosmic twins. They're born together, sharing a single quantum state. Even when separated by vast distances, they remain linked, mirroring each other's behavior instantaneously. This isn't just a quirky coincidence, it's a fundamental feature of the universe. To understand how this works, we need to talk about superposition. Think of a spinning coin. While it's in the air, it's neither fully heads nor tails, it's both at once. Quantum particles exist in this blurred state until measured, at which point their wave function collapses and they choose a definite state. Here's the twist: with entangled particles, measuring one forces its twin into a corresponding state, no matter how far apart they are. Einstein found this idea deeply unsettling. Along with his colleagues Podolsky and Rosen, he argued that quantum mechanics must be incomplete, dubbing entanglement spooky action at a distance. They proposed the Fermi paradox, suggesting there must be hidden variables guiding this behavior. But decades later, experiments by physicists like Elaine Aspect closed those loopholes, proving entanglement is real and even spookier than Einstein imagined. So, if particles can whisper to each other across the galaxy, what's stopping civilizations from using this as their cosmic telephone? That's where things get even more fascinating. But here's where the story takes a sharp turn. Classical physics, the rulebook that guided scientists for centuries, crumbles when faced with quantum entanglement. Picture Newton's universe predictable, orderly, where objects move like clockwork and information can't travel faster than light. Now toss that rulebook out the window. Entanglement laughs at the idea of locality, the notion that objects are only influenced by their immediate surroundings. In Newton's world, if you flick a pebble in a pond, the ripples take time to reach the shore. But entangled particles don't wait for ripples. Change one, and its partner responds instantly, even if they're light years apart. It's as if the universe has a hidden switchboard connecting them, bypassing the speed of light entirely. This defiance of classical logic led physicist John Bell to devise a way to test whether hidden variables, Einstein's proposed cheat codes, could explain entanglement. Bell's theorem became the ultimate referee. If hidden variables existed, quantum predictions would cap out at a certain limit. But experiment after experiment, from Elaine Aspect's pioneering work to recent loophole-free tests, shattered that limit. The particles didn't just break the rules, they rewrote them. To grasp how bizarre this is, let's revisit Schrödinger's infamous cat. In this thought experiment, a cat in a box is both alive and dead until someone looks inside, a metaphor for quantum superposition. Now imagine two entangled cats in separate boxes, light years apart. Open one box, and not only does its cat choose a state, but the other cat instantly mirrors it. No signal, no delay. Classical physics can't explain this. It's like flipping a coin in New York and seeing its twin in Tokyo land the same way without any time for light to travel between them. This isn't just theoretical magic. Labs worldwide have replicated these results, proving that entanglement isn't a fluke. It's the universe's way of showing us how little we truly understand. So if particles can defy space and time, what else might be possible? The answer could rewrite not just physics, but our place in the cosmos. Now let's take this quantum weirdness to the next level. What if entanglement isn't just a quirk of physics, but the universe's ultimate communication network? Imagine an advanced civilization out there, not bothering with radio waves or lasers, but instead using entangled particles as their cosmic Morse code. Here's how it could work. If you have a pair of entangled particles, manipulating one instantly affects its partner, no matter the distance. In theory, you could flip the state of one particle here on Earth, and its twin halfway across the galaxy would respond in sync. No waiting for light years, no signal delay, just instant communication. It's like having a telephone line that bypasses the speed of light entirely. But hold on, because physics throws a wrench in this idea with the no communication theorem. This rule says you can't use entanglement to send meaningful information faster than light. Why? Because while the particles are linked, the changes you observe are random. You can't force an entangled particle into a specific state to spell out hello. To aliens, it's more like flipping a coin and hoping the other side matches. Yet where there's a will, there's a workaround. Enter quantum teleportation protocols. These clever tricks let you transfer the quantum state of one particle to another, effectively teleporting information without breaking the speed of light. Here's the catch: you still need a classical signal to decode the message, which moves at light speed. So while the quantum link is instantaneous, the full message isn't. But what if an advanced species has cracked the code? Maybe they've found a way to pre-arrange entangled pairs as a shared language, like a cosmic version of a one-time pad cipher. Or perhaps they've discovered loopholes we haven't even dreamed of yet. After all, if entanglement teaches us anything, it's that the universe loves to surprise us. So next time you look up at the stars, consider this. The silence of space might not be silence at all. We could be swimming in a sea of quantum messages, whispering between civilizations. We just haven't learned to listen yet. Now let's shift our gaze from theory to action. If quantum entanglement truly is the universe's hidden communication network, how do we start eavesdropping on the conversation? The answer lies in a new kind of cosmic detective work, Galactic Archaeology, for the quantum age. Picture this: every time an advanced civilization manipulates entangled particles, they might leave faint fingerprints on the fabric of reality. Scientists are now exploring ways to spot these quantum imprints in places like the cosmic microwave background, the afterglow of the Big Bang. Tiny irregularities in this ancient light could theoretically hold traces of artificial entanglement, like cosmic graffiti left by distant engineers. Then there's the hunt for strange particle behavior in nebulas and star clusters. Normally, quantum entanglement decays quickly in noisy environments. But what if alien megastructures are actively sustaining these connections? We might detect unnatural patterns particles staying mysteriously synchronized across light years, defying the usual rules of decoherence. Projects like Breakthrough Listen, famous for scanning radio waves, are now expanding their search to include quantum technosignatures. They're developing tools to spot anomalies that classical physics can't explain, perhaps a star system emitting particles that remain eerily correlated with no natural cause. It's like searching for a needle in a haystack, except the needle might be rewriting the laws of physics. The challenge: distinguishing alien engineering from natural quantum phenomena. But here's the thrilling part. If we do find proof of artificial entanglement, it won't just reveal extraterrestrials, it'll expose an entire galactic infrastructure humming beneath our notice. The universe's quiet corners might be bustling with quantum handshakes we're only beginning to decipher. Now let's tackle one of space's biggest mysteries, the Fermi Paradox. If the universe is so vast, why haven't we heard from anyone else? The answer might be hiding in quantum entanglement. Imagine this: advanced civilizations aren't using radio waves or lasers to talk. They're using something far more subtle: quantum connections we can't even detect yet. It's like trying to listen to a phone call with a tin can while everyone else is texting. We're stuck with old technology, missing an entire galactic conversation happening right under our noses. This leads us to the Zoo Hypothesis 2.0. What if aliens aren't ignoring us? What if they're watching through quantum entangled probes, observing Earth like a cosmic nature documentary? These probes could be everywhere, woven into the fabric of space itself, completely invisible to our current tools. Picture the galaxy not as a silent void, but as a bustling quantum internet. Civilizations could be exchanging information instantly across thousands of light years, their messages hidden in the behavior of particles. While we're still shouting into the dark with radio signals, they're operating on a whole different level of physics, so the great silence might not be silence at all. We're just listening for the wrong things. If we crack the quantum code, we might finally hear the universe's hidden chatter and realize we were never alone to begin with. But here's something even more mind-bending. What if ancient civilizations already knew about quantum entanglement? Long before modern science, myths and legends spoke of invisible threads connecting everything in the cosmos. Take Indra's net from Hindu philosophy, a vast web where every jewel reflects all the others, mirroring the way entangled particles instantly influence each other across space. Or Yggdrasil, the Norse world tree, whose roots and branches tie all realms together almost like a cosmic network of quantum links. These stories might sound like fantasy, but what if they were early attempts to describe something real? Ancient texts are full of metaphors that eerily resemble quantum phenomena. The Tao Te Ching speaks of the universe as an unbroken whole, while indigenous traditions describe dreams and visions that transcend distance, echoes of non-local connections. Could these cultures have glimpsed the quantum fabric of reality, even without the math to prove it? It's tempting to dismiss these parallels as coincidence, but the similarities are hard to ignore. Maybe myths weren't just stories. Maybe they were humanity's first clumsy sketches of a truth we're only now uncovering with particle colliders and telescopes. Imagine if the knowledge of entanglement was once widespread, lost to time, and buried in symbolism. So next time you hear an old tale about cosmic webs or invisible bonds, ask yourself, was this just poetry, or a clue left behind by ancestors who saw deeper into the universe than we realized? The answers might be hiding in plain sight, woven into the stories we've been telling for thousands of years. Now let's turn our gaze toward the darkest corners of the cosmos, black holes. These cosmic monsters might seem like the last place you'd look for quantum connections, but they could actually be nature's perfect entanglement hubs. Picture this: when particles get too close to a black hole's edge, they don't just vanish. Thanks to Hawking radiation, they leave behind ghostly imprints and tangled pairs where one particle escapes, while its twin falls into the abyss. This means black holes might not destroy quantum links, they could stretch, amplify, or even preserve them across unimaginable distances. Here's where things get even wilder. The ER=EPR conjecture suggests that entangled particles might be connected by microscopic wormholes, tiny bridges in spacetime. That means two black holes could secretly be one, linked through a quantum shortcut. If that's true, advanced civilizations might not need starships to cross the galaxy. They could use black holes as relay stations, sending information through these hidden tunnels faster than light could ever travel. Imagine a network of supermassive black holes at the hearts of galaxies, each one a node in a vast quantum internet. A civilization could encode a message in entangled particles, drop them into a black hole, and poof, the data emerges light years away instantaneously. No waiting, no lag, just pure cosmic communication. It sounds like science fiction, but the math hints it might be possible. So next time you see a black hole in a documentary, don't just think of it as a cosmic vacuum cleaner. It might be the universe's most powerful telephone, a quantum switchboard humming with invisible connections, waiting for someone smart enough to dial in. Now let's take a step even further into the quantum rabbit hole. What if entanglement doesn't just connect points in space, but also moments in time? The idea of sending messages backward might sound like pure fantasy, but quantum mechanics has a way of turning the impossible into the merely baffling. Consider the delayed choice experiment, a mind-bending test where decisions made in the present seem to influence the past behavior of particles. It's as if the universe waits to see what you'll do before deciding how things unfolded. If entanglement can create these kinds of temporal loops on a small scale, could advanced civilizations use it to send signals across time itself? Picture this: what if the reason we haven't found a clear signal from extraterrestrials isn't because they're silent, but because their messages are entangled in our past? Imagine SETI's search for alien signals uncovering a pattern buried in old radio data. Reply that was always there, waiting for us to piece it together. The implications are staggering. A civilization could encode a message in entangled particles, knowing it would appear in their own history or even in ours. This isn't just wild speculation. The math suggests retrocausal effects might be possible within quantum rules. If true, the universe's communication network wouldn't just span space, it would weave through time, turning every moment into a potential node in a galactic conversation. So the next time you hear an old radio crackle with static, ask yourself, could that noise be more than just noise? Could it be a message from the future, whispering through the quantum threads of time? Now, let's shift our gaze to one of the universe's greatest mysteries: dark matter. What if this invisible substance isn't just holding galaxies together, but also acting as the cosmic glue for quantum entanglement? Think of dark matter as the unseen scaffolding of the universe. We know it makes up about 85% of all matter, yet it doesn't interact with light or ordinary matter the way atoms do. But here's the twist. Some scientists believe dark matter could be the perfect medium for sustaining entanglement on a galactic scale. Imagine dark matter filaments, those vast, web-like structures stretching across the cosmos, as the universe's hidden nervous system, transmitting quantum signals between stars and civilizations. One leading candidate for this quantum glue actions. These hypothetical particles are incredibly lightweight and could theoretically form a diffuse, galaxy-spanning network. Research suggests actions might naturally entangle over vast distances, creating a ready-made communication channel. Picture civilizations tapping into this dark matter web, using actions to send messages faster than light, or even across time. And it's not just speculation. Experiments like the Action Dark Matter experiment are already hunting for these elusive particles. If they exist, actions could explain not just dark matter, but also how entanglement might work on cosmic scales. The implications are profound. Dark matter might not just be the universe's hidden mass, it could be its hidden internet, quietly connecting everything. So next time you look up at the night sky, remember, the emptiness between stars might not be empty at all. It could be buzzing with quantum chatter, a silent conversation written in the language of dark matter. But let's bring this cosmic puzzle closer to home, right down to the living world around us. Quantum entanglement isn't just a phenomenon of distant stars or lab experiments. It might be woven into the very fabric of life itself. Take photosynthesis, for example. Studies suggest that plants use quantum coherence to transfer energy between molecules with near-perfect efficiency. It's as if they're tapping into a hidden quantum network to harness sunlight. Now, stretch that idea across the cosmos. If life on Earth can exploit quantum effects, what about life out there? Could alien organisms have evolved to sense or even manipulate entanglement directly? Imagine a planet where bioluminescent creatures glow not just for communication, but as living quantum antennas, tuning into the universe's invisible web. Their light might not just be a chemical reaction, it could be a beacon, signaling across entangled pathways we're only beginning to understand. Birds add another layer to this mystery. Some species navigate using Earth's magnetic field, and there's controversial research suggesting quantum entanglement in their eyes could act like a biological compass. If migratory birds are subtly quantum connected to the planet's magnetism, what's stopping an alien species from evolving to feel the entanglement between stars? Picture a civilization that doesn't need telescopes because their very biology is wired into the quantum fabric of space. Of course, this is speculative, even contentious. But that's what makes it thrilling. The line between biology and quantum physics might be blurrier than we thought. And if life elsewhere has harnessed entanglement in ways we can't yet imagine, the universe could be far more interconnected and far stranger than we ever dreamed. So the next time you see a firefly flicker or a flock of birds turn in perfect unison, ask yourself, are we witnessing the first hints of a quantum dance shared by all living things? Now, let's take this idea to the next level beyond biology and into the realm of advanced alien technology. Picture a civilization so advanced that they've built megastructures around stars, not just to harness energy, but to tap into the quantum fabric of the universe itself. Imagine a Dyson sphere, but instead of merely capturing sunlight, it's a colossal quantum computer, using entangled particles to perform calculations at speeds we can't even fathom. Here on Earth, our quantum computers are still in their infancy, solving niche problems with a handful of qubits. But out there, an alien civilization might have scaled this up to a galactic internet, a network where information travels instantaneously across light years, defying the speed of light. They could be using entanglement to link planets, stars, even entire galaxies in a seamless web of communication. While we struggle with quantum decoherence, they've mastered it, turning the universe itself into their processor. This brings us to the Kardashev scale, a way to measure a civilization's technological prowess. A Type 3 civilization controls the energy of an entire galaxy. Now, imagine if their power source wasn't just stars, but the quantum connections between them. Entanglement could be the ultimate energy grid, allowing them to distribute and manipulate power without wires, without delay, across unfathomable distances. Think about it. What if the missing signatures of advanced aliens aren't radio waves or megastructures, but subtle quantum manipulations we're only starting to detect? The universe might be buzzing with quantum traffic, and we're just learning the language. So next time you hear about a breakthrough in quantum computing, remember we might be taking our first steps into a conversation that's been going on for billions of years. But here's the exciting part: humanity isn't just speculating about this quantum future. We're already taking our first steps toward reaching out across the cosmos. Projects like the quantum experiments at space scale, or QUES, are pushing the boundaries of what we thought was possible. Launched by China in 2016, QUES sent entangled photon pairs from space to ground stations over 700 miles apart, smashing previous distance records. This wasn't just a lab experiment, it was a proof of concept that entanglement could survive the harsh environment of space, a critical test for any future interstellar communication network. Now, picture this: what if we scaled this up? Imagine a satellite network in Earth's orbit, firing entangled photons toward a receiver near Mars or even Alpha Centauri. The moment we detect a change in one particle here, its entangled twin would respond instantly, no matter how far apart they are. It's like sending a cosmic ping across the stars, a handshake that bypasses the speed of light entirely. But the real game changer: we wouldn't just be sending random signals. Scientists are already working on protocols to encode meaningful data into these quantum links. Think of it like Morse code, but instead of dots and dashes, we'd use the spin states of particles to transmit complex messages. And here's the mind-blowing part: if an advanced civilization out there is already using this technology, our first quantum message might not go unanswered. Of course, the challenges are enormous. Maintaining entanglement over interstellar distances means shielding particles from cosmic radiation and other interference. And we'd need receivers sensitive enough to detect these subtle quantum changes. But here's the thing: every breakthrough starts with a wild idea. Just over a century ago, radio waves seemed like magic. Today, they're how we listen to the universe. Quantum entanglement could be the next leap, our ticket to joining a conversation that might have been happening since the dawn of time. So while we're still in the early days, the pieces are falling into place. From lab experiments to space missions, humanity is inching closer to that first quantum handshake with the stars. And who knows, the reply might already be on its way. Now, let's tackle the next big puzzle: how would we even recognize an alien quantum message if it reached us? It's one thing to send entangled signals into the cosmos, but decoding an extraterrestrial protocol is a whole other challenge. Think of it like stumbling upon an ancient manuscript written in a language no one's ever seen. The Voynich manuscript, that cryptic medieval text filled with bizarre illustrations and undecipherable script, has baffled scholars for centuries. Now, imagine that same mystery, but instead of ink on parchment, it's encoded in the quantum states of particles. Here's where quantum Shannon theory comes into play. Just like Claude Shannon's work laid the foundation for modern communication by quantifying information, quantum Shannon theory does the same for qubits. It's the rulebook for how information can be stored, transmitted, and retrieved in a quantum system. An advanced civilization wouldn't just send random entangled particles. They'd structure their messages using error correction codes to prevent cosmic interference from scrambling the data. These codes might look like patterns in the way particles are entangled, or specific sequences in their spin states. So how do we spot these patterns? One approach is to look for statistical anomalies in quantum data, clusters of entanglement that don't match natural phenomena. Just as radio astronomers search for narrowband signals that stand out against cosmic noise, quantum physicists could hunt for entanglement that's too neat to be random. Another clue might come from repetition. If we detect the same sequence of quantum states appearing multiple times, especially in ways that defy probability, that could be a deliberate signal, an alien hello etched into the fabric of reality. Of course, the biggest hurdle is that we don't know what an alien quantum language would even look like. Their protocols might use higher dimensional entanglement or exploit physics we haven't discovered yet. But that's what makes this so thrilling. Every time we push the boundaries of quantum communication, we're not just building tools for humanity, we're learning the vocabulary of the cosmos. And one day, that vocabulary might include a message from the stars. So while we're still in the early stages of this cosmic detective work, the tools are coming together. From quantum algorithms to deep space detectors, we're assembling the pieces needed to listen not just for radio waves, but for whispers in the quantum void. And who knows, the first message we decode might not just change science, it could change everything. Now, let's take a wild but fascinating turn. What if quantum entanglement isn't just a cosmic communication tool, but a backdoor into the very fabric of reality? This brings us to the simulation hypothesis, the idea that our universe might be an advanced digital construct. And here's where things get mind-bending. If we're living in a simulation, quantum entanglement could be the glitches in the system, tiny cracks in the code that reveal how the program works. Think of it like finding a bug in a video game. Sometimes, when the game glitches, you catch a glimpse of the underlying mechanics, textures failing to load, or objects clipping through walls. In the same way, anomalies in quantum coherence might be hints that we're peeking behind the curtain of the universe. For instance, if entangled particles suddenly stop behaving as predicted, it could mean the simulation is struggling to maintain consistency across vast distances. These irregularities might be our first clues that reality isn't as solid as it seems. Now, imagine an advanced civilization that's figured this out. They wouldn't just use entanglement to send messages, they might exploit it to hack the simulation itself. By manipulating quantum states in precise ways, they could potentially rewrite the rules of their local reality, bending physics to their will. It's like finding admin access to the cosmos. They could create matter out of nowhere, teleport objects instantly, or even tweak the laws of nature. This idea isn't just sci-fi speculation. Some physicists have seriously considered whether quantum weirdness, like particles being in multiple states at once, points to a universe running on computational limits. After all, even the most powerful computers have to approximate complex calculations. If our reality is a simulation, quantum superposition might be its way of saving processing power. So where does that leave us? If entanglement is the universe's source code, then decoding it could be the ultimate scientific breakthrough. it wouldn't just connect us to alien civilizations, it might let us join them in shaping reality itself. And while this sounds like something from a futuristic thriller, the deeper we dive into quantum mechanics, the harder it becomes to dismiss the possibility. The next time you hear about a quantum experiment defying expectations, ask yourself, are we seeing the work of an advanced species, or are we staring straight into the programming of existence? Either way, the implications are staggering. But here's where the mystery deepens. What if quantum entanglement isn't just about particles communicating, but about something far more profound? What if it's the hidden thread weaving consciousness itself into the fabric of the universe? This idea isn't just wild speculation. Some scientists and philosophers argue that consciousness might arise from the very quantum connections that bind the cosmos together. Take panpsychism, for example. This theory suggests that consciousness isn't something that emerges solely from complex brains. It's a fundamental property of reality, like mass or energy. In this view, even the tiniest particles might have a rudimentary form of awareness. And if that's true, then quantum entanglement could be the mechanism that links these tiny sparks of consciousness into the vast, interconnected web we experience as mind. One of the boldest versions of this idea comes from the Orch, or theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. They suggest that consciousness arises from quantum processes happening inside the microtubules of brain cells. These tiny structures could harness entanglement to create coherent, unified experiences, like a symphony of quantum vibrations giving rise to thought and perception. If they're right, then every moment of awareness might be a dance of entangled particles. Now, consider this. People who have had profound psychedelic experiences often describe a sense of oneness with the universe, as if the boundaries between self and cosmos dissolve. Could these experiences be glimpses into the quantum-connected nature of reality? Some researchers think so. They argue that psychedelics might temporarily disrupt the brain's usual filtering mechanisms, letting us perceive the underlying entanglement that binds everything together. So here's the big question. If entanglement connects particles across galaxies, could it also connect minds? Could there be a cosmic consciousness, a universal mind woven into the very fabric of space and time? It's a staggering thought. Imagine civilizations not just communicating through entanglement, but actually sharing thoughts, emotions, or even memories across the void. Of course, this is all speculative, but the deeper we look into quantum mechanics and consciousness, the harder it becomes to ignore the eerie parallels. Whether it's the unity described by mystics or the strange behavior of entangled particles, the universe seems to be hinting at a connection far deeper than we've ever imagined. So next time you gaze at the stars, ask yourself, are we alone in our thoughts, or is the cosmos itself alive with a shared awareness, humming silently through the quantum web? The answer might just redefine what it means to be conscious. Now, let's shift our gaze to something even more mind-bending: time crystals. Imagine a clock that never winds down, a structure that ticks forever without any energy input. That's the bizarre promise of time crystals, a strange new phase of matter where atoms move in a repeating pattern, not just in space, but in time itself. Unlike ordinary crystals, which have a fixed arrangement in space, time crystals break the symmetry of time, oscillating indefinitely in a state of perpetual motion. And here's the kicker: quantum entanglement might be the glue holding these cosmic oddities together. Think of a time crystal as a dance frozen in eternity. The atoms inside it don't settle into equilibrium, they keep cycling through their motions, locked in an endless loop. This isn't science fiction. In 2016, researchers created the first time crystals in the lab using chains of entangled ions. The entanglement between particles kept the system out of equilibrium, allowing it to pulse like a heartbeat that never fades. Now, picture this on a galactic scale. What if advanced civilizations harnessed time crystals as the ultimate clocks, perfectly synchronized across light years, or even as message repeaters, storing quantum information in their unbreakable rhythms? Pulsars might already be hinting at this possibility. These spinning neutron stars emit beams of radiation with such precise regularity that they rival atomic clocks. Some scientists speculate that pulsars could be natural time crystals, their rotations sustained by quantum effects deep within their cores. If that's true, then the universe might be littered with these cosmic lighthouses, blinking in perfect sync across the void, a ready-made network for interstellar communication. So here's a wild thought. What if alien civilizations aren't just using entanglement to send messages, but are encoding them in the very fabric of time crystals? A pulsar's rhythm could carry data, its pulses tweaked by quantum manipulations we can't yet detect. Or perhaps time crystals act as galactic archives, preserving knowledge in their eternal loops, waiting for a species smart enough to read them. Of course, this is frontier science, and time crystals are still shrouded in mystery. But if they exist naturally, or if someone out there has learned to engineer them, then the universe might be far more alive with information than we ever dreamed. The stars themselves could be whispering to us, not just through light, but through the silent, unending tick of time. Now, let's take a detour into the strange and unexplained UFO sightings. These mysterious objects darting across our skies might not just be advanced spacecraft. What if there's something even weirder, tied directly to the quantum world? Picture this: a UFO vanishes in the blink of an eye, not because it's moving fast, but because it's collapsing like a quantum wave function. One moment it's there, the next poof it's gone, as if it was never more than a probability. This idea isn't just wild speculation. Jacques Vallée, a renowned scientist and UFO researcher, has long argued that these phenomena might not be extraterrestrial in the traditional sense. Instead, he suggests they could be interdimensional entities slipping in and out of our reality like particles, popping in and out of existence. If quantum entanglement connects distant points in space, could it also bridge different dimensions? Maybe what we call UFOs are probes or observers from another layer of reality, appearing only when their wave function chooses to manifest. Think about the way some UFOs defy physics: instant acceleration, sudden stops, no sonic booms. It's as if they're not bound by the rules we know. Now, imagine an advanced civilization that's mastered quantum coherence, using entanglement to project objects, or even consciousness, into our dimension. These visitors might not be aliens in spaceships, but quantum entities, flickering in and out like glitches in the cosmic code. And here's the playful twist: what if we're not just being watched by aliens, but by quantum observers? In quantum mechanics, the act of observation changes the system. Could UFOs be the universe's way of measuring us, collapsing possibilities into reality whenever they appear? It's a dizzying thought, one that blurs the line between physics and metaphysics. Of course, this is all speculative, but it's a fascinating lens to view these mysteries through. Whether UFOs are interdimensional travelers, quantum probes, or something else entirely, their behavior eerily mirrors the spookiness of the quantum world. So next time you hear about a UFO sighting, ask yourself, are we looking at visitors from another star or another state of existence? Now, let's shift gears and consider the darker side of this quantum web. What happens if we start tampering with the very fabric that might connect civilizations across the galaxy? Imagine entanglement as a delicate cosmic thread. Pull it the wrong way, and the whole tapestry could unravel. The idea of hacking into galactic-scale entanglement sounds like something straight out of science fiction, but the risks are very real. Picture this: a civilization eager to tap into this quantum network accidentally triggers what physicists call decoherence. It's like dropping a stone into a still pond. The ripples could disrupt the delicate quantum states holding the network together. Suddenly, messages that once traveled instantly between stars dissolve into noise, and the universe's hidden communication system goes dark. Science fiction has toyed with this idea for decades. Stories of quantum pollution depict advanced races scrambling to fix their broken networks after reckless experiments. Think of it as cosmic littering, except instead of plastic in the ocean, it's scrambled qubits in space-time. And if entanglement really does link civilizations, our mistakes might not just affect us. We could be the noisy neighbors disrupting an entire galaxy's quiet conversation. This isn't just theoretical. Even here on Earth, quantum researchers handle entanglement with extreme care. One wrong measurement, and the fragile connection between particles is lost. Now scale that up to interstellar levels. What if our attempts to talk via entanglement accidentally collapse the very channels we're trying to use? Or worse, what if we stumble into a galactic-scale firewall, triggering safeguards built by civilizations far older than ours? The ethical dilemma is clear. If entanglement is the universe's shared resource, do we have the right to experiment with it recklessly? Or should we approach it with the same caution we'd use when handling an ancient, irreplaceable artifact? Some scientists argue for a quantum prime directive, a set of rules to prevent contamination of this cosmic network until we truly understand its rules. Of course, this isn't just about avoiding catastrophe. It's about respect. If entanglement connects all of us, then every experiment, every signal we send, is like tapping on a shared wall in the cosmic apartment building. The question isn't just can we use this technology, it's should we? And if we do, how do we ensure we're not the ones who accidentally unplug the galaxy's internet? But here's a twist that might make you see the cosmos in a whole new light. What if the ancient stories of gods and deities weren't just myths, but glimpses into a reality where higher dimensional beings manipulate quantum entanglement like puppet strings? Imagine deities not as supernatural figures, but as entities operating in dimensions beyond our perception, using entanglement as their tool to shape reality. This idea isn't as far-fetched as it sounds. Modern physics has its own version of hidden forces. Think of hidden variables, the unseen factors that might govern quantum behavior. Could these variables be the fingerprints of something, or someone operating behind the scenes? Some scientists and philosophers have even speculated that entanglement might be the bridge between science and spirituality, a shared language that explains both the mysteries of the quantum world and the profound sense of interconnectedness described in religious texts. Take the Hindu concept of Indra's net, a cosmic web where every jewel reflects all others, a striking metaphor for entanglement. Or the Christian idea of an omnipresent God, echoing the non-local nature of quantum connections. Even indigenous traditions speak of a living, woven universe, where every action ripples across the whole, these aren't just poetic ideas, they might be intuitive understandings of a quantum-linked cosmos passed down through generations. The implications are staggering. If entanglement truly unites everything, then the divine might not be separate from the physical world, but woven into its very fabric. Prayer, meditation, or ritual could be ways of tuning into this quantum network, aligning ourselves with its rhythms, and those moments of mystical oneness. Perhaps they're fleeting experiences of the universe's underlying entanglement, a peek behind the curtain. This isn't about replacing science with spirituality, or vice versa. It's about recognizing that both might be pointing to the same profound truth, that the universe is far more connected, far more mysterious than we've ever imagined. And if that's the case, then the age-old quest for meaning and the cutting-edge search for quantum understanding might just be two sides of the same cosmic coin. Now, let's take a playful detour into something that might make you chuckle, or maybe even rethink your horoscope. What if astrology, often dismissed as pseudoscience, actually had a hidden thread of quantum truth? Picture this: your zodiac sign isn't just about personality traits, but a subtle reflection of your place in a vast, entangled cosmic web. It sounds like science fiction, but consider this. Stars and planets emit particles, photons, neutrinos, that could, in theory, become entangled with particles here on Earth. If entanglement links distant parts of the universe instantaneously, could celestial bodies influence us not through mystical energy, but through quantum connections? Some fringe researchers have floated the idea that planetary alignments might tweak quantum states in ways we don't yet understand. Of course, mainstream science isn't ready to endorse your daily horoscope. But here's where it gets intriguing. Serious studies have shown that cosmic rays, high-energy particles from space, can affect quantum systems on Earth. Labs have even reported slight variations in particle behavior during solar flares or eclipses. Could there be a sliver of truth buried beneath the astrology memes? The key is balance. While astrology, as we know, it leans heavily on symbolism and interpretation, the underlying idea that the cosmos might influence us through quantum-scale interactions isn't entirely absurd. It's a reminder that the universe is full of surprises, and sometimes the line between whimsy and science is thinner than we think. So next time you read your horoscope, take it with a grain of stardust. But also remember, in a quantum-entangled universe, stranger things have already been proven true. Now, let's shift gears from cosmic speculation to something tangible. What if humanity could actively participate in this galactic quantum conversation? Imagine building our own quantum beacon, a deliberate signal to the stars, using the very principles of entanglement we've been exploring. The idea isn't as far-fetched as it sounds. Projects like the quantum experiments at space scale, or QUES, have already taken the first steps by testing entanglement over record-breaking distances. China's Misha satellite, for example, successfully sent entangled photons between ground stations and orbit, proving that quantum communication can work on a planetary scale. But why stop there? Picture this: a network of lunar quantum labs harnessing the Moon's stable environment to create a pristine entanglement hub. Without Earth's atmospheric interference, the Moon could serve as the perfect relay station for interstellar quantum messages. Scientists have even proposed using lasers to entangle particles across vast cosmic distances, essentially turning our solar system into a giant quantum transmitter. Now, here's where you come in. What if we crowdfunded a modern-day Arecibo message, but this time encoded in entangled particles? Instead of radio waves, we'd send a quantum signal, a deliberate hello, to any civilization tuned into the same cosmic frequency. Crowdsourcing such a project wouldn't just fund the science, it would make humanity an active participant in the search for cosmic neighbors. This isn't just about technology, it's about unity. A quantum beacon would be a symbol of our species' curiosity and collaboration, a testament to our desire to reach beyond our planet. Whether or not anyone answers, the act of sending that signal would redefine our place in the universe. So, what do you think? Should Earth start building its quantum megaphone? The conversation is just beginning, and you're invited to be part of it. But here's something even more intriguing. What if some people already sense this quantum web without any instruments? Scientists, and even self-proclaimed psychics, have shared eerie accounts of feeling what they describe as the universe's hidden connections. One physicist working on quantum coherence experiments reported sudden, overwhelming sensations of being linked to distant colleagues during critical trials. Moments later, their data would show unexplained correlations. Another researcher anonymously posted about recurring dreams of a shimmering network, only to later discover his team had accidentally stabilized entangled particles in a nearly identical pattern. Then there are the stories from everyday people. On Reddit, threads buzz with anecdotes about strange synchronicities during quantum-themed events. One user described hearing a high-pitched tone the exact moment a friend, thousands of miles away, successfully entangled photons for the first time. Another shared how their cat began pawing at empty air in rhythmic bursts, later matched to the timing of a major quantum lab's pulse sequences. Skeptics dismiss these as coincidences, but the sheer volume of similar reports makes you wonder. The key here isn't to prove or debunk these claims, but to spotlight how deeply entanglement captivates the human imagination. Whether it's hard science or personal experience, the idea of an invisible web resonates across cultures and disciplines. Maybe that's the real power of quantum mysteries. They blur the line between data and intuition, leaving room for awe in an age of algorithms. So, what's your take? Have you ever felt a strange connection you couldn't explain? Drop your stories below, because in a universe this weird, even the wildest tales might hold a kernel of cosmic truth. Now let's zoom out and see the bigger picture. Imagine a future where quantum entanglement isn't just a scientific curiosity, but the glue holding civilizations together across the galaxy. Picture a universe where distant species, separated by light years, share a silent understanding not through radio waves or laser signals, but through the very fabric of reality itself. This isn't just science fiction. If entanglement truly connects particles instantaneously, regardless of distance, it could rewrite the rules of communication. Wars over resources or territory might become unthinkable when entire civilizations feel each other's joys and struggles as their own. Think of it like a cosmic empathy network, where harm to one ripple affects all. Some researchers even speculate that advanced civilizations may have already tapped into this. What if the reason we haven't detected alien signals isn't because they're silent, but because they're speaking a language woven into space-time? A language we're only beginning to decipher. And here's the most hopeful part: humanity might be on the verge of joining this conversation. Projects like quantum satellites and entanglement-based networks are our first baby steps toward a galactic handshake. One day, we might look back and realize that the real great filter wasn't extinction, but learning to listen to the universe's hidden whispers. So as we stare up at the stars, remember, the night sky might not be silent after all. It could be buzzing with connections we're just starting to sense. The question isn't whether we're alone, it's whether we're ready to join the cosmic chorus. What do you think? Could entanglement be the key to uniting the galaxy? Let's dream big in the comments. So where does this leave us? Quantum entanglement isn't just a quirk of physics. It might be the universe's oldest and most sophisticated social network. Think about it, a hidden web linking every star, every planet, every civilization that's ever wondered if they're alone. The cosmos could be whispering in a language we're only starting to decode, not with words, but through the silent dance of particles across unimaginable distances. Carl Sagan once said we're made of star stuff, but now we might need to update that. We're not just star stuff, we're entangled star stuff, woven into the same cosmic fabric as everything else. That's the real magic here. The night sky isn't a cold, empty void. It's a living, breathing network, humming with connections we're just beginning to sense. So here's the big question. Is the galaxy already talking behind our backs? Are we, the newcomers, stumbling into a conversation that's been going on for billions of years? Drop your wildest theories in the comments. Let's keep this cosmic dialogue going. And if you're as fascinated by this invisible thread tying the universe together as I am, don't forget to hit like, subscribe, and ring that notification bell. The next breakthrough in quantum entanglement could drop any day, and you won't want to miss it. Until then, keep looking up and listening for the whispers.